Hello everyone. In this lesson, I'll complete solving exercises of lesson 4 curve sketching. We reach number 8. I'll skip this question because it is needed numerical methods, and these methods are not within the curriculum of grade 12. So I'll skip it. Number 9, sketch the graph of the function f of x equal x power 2 plus 1 over x. The domain of this function is all real number except 0, since 0 make the denominator 0. For x-intercept, we set y equals 0 and find the value of x. 0 equal to x power 2 plus 1 over x, cross multiplication. Then x power 2 plus 1 equals 0. Then x power 2 equal negative 1, x equal negative positive square root negative 1, not a real number, therefore there is no x-intercept. For y-intercept, we set x equals 0 and find the value of y, therefore y equal to 0 plus 1 over 0 equal 1 over 0, undefined term, there is no y-intercept. For symmetric, the function equal to even function plus even function over odd function equal to even over odd equal to odd function. Therefore, the function is symmetric with the origin point. For vertical asymptote, we say the denominator of the function equals 0, x equals 0. Therefore, x equals 0 is a vertical asymptote for this function. For horizontal asymptote, we find the limit of the function when x approaches to negative or positive infinity, x power 2 plus 1 over x, since the degree of the numerator greater than the degree of the denominator, then negative positive infinity. Therefore, there is no horizontal asymptote. For a slant asymptote, the function equal to x power 2 over x plus 1 over x equal to x plus 1 over x. Therefore, y equal x is a slant asymptote for this function. To find the interval of increasing and decreasing and the local minimum and the maximum extrema, we find f prime of x. The denominator x times the derivative of the numerator 2x minus the numerator x power 2 plus 1 times the derivative of the denominator 1 over denominator square equal to 2x power 2 minus x power 2 minus 1 over x power 2 equal to 2x power 2 minus x power 2, x power 2 minus 1 over x power 2. Set it equals 0, cross multiplication, then x power 2 minus 1 equals 0, then x equal to negative positive 1. We have two critical points. And the first derivative equals 0, undefined when x equals 0, but 0 is not within the domain of this function. Therefore, x equals 0 is not a critical point, but we set it in the number line. Now we find the sign of the first derivative before and after this critical point, negative 1, 0, 1. Before negative 1, take negative 2, negative 2 square, 4 minus 1, 3 over 4, positive value. Between negative 1 and 0, take negative 1 half, negative 1 half square, 1 over 4 minus 1, negative value, negative over positive value, negative value. Between 0 and 1, also the first derivative is negative. A greater than 1, 2 power 2, 4 minus 1 is positive value. Therefore, the function is increasing from 1 to positive infinity. X equal negative 1 is a local maximum value. X equal 1 is local minimum value. Therefore, negative infinity to negative 1 union 1 to positive infinity are the intervals of increasing, and from negative 1 to 0 union from 0 to 1 are decreasing intervals, and negative 1 f of negative 1 is a local maximum value, and 1 f of 1 is a local minimum value. For the inflection point, we find the second derivative of this function, f double prime of x. This is the first derivative. The denominator times the derivative of numerator to x minus the numerator x power 2 minus 1 times the derivative of the denominator to x over denominator square. Simplify this, 2x times x power 2, 2x power 3 minus 2x times x power 2, 2x power 3, negative 1 times negative positive 2x over x power 4. 2x power 3 minus 2x power 3 is 0. X with x power 4, the answer is 2 over x power 3. Set it equals 0. Then 2 equals 0. Contradiction. There is no critical value. Also, x equals 0 make the second derivative undefined, but 0 is not within the domain of this function. Now we find the sign of the second derivative before and after 0. Before 0, take negative 1, 2 over negative 1 power 3 negative. When x greater than 0, 2 over 1 positive value. Therefore, the function is convex from negative infinity to 0, concave from 0 to positive infinity, and 0 f of 0 is not an inflection point. From negative infinity to 0, the function here is convex. From 0 to positive infinity, the function is concave. The graph of this function will be, we have a slant asymptote at y equal x and vertical asymptote when x equals 0. The function is concave from 0 to positive infinity and convex from negative infinity to 0. Also, the interval of increasing is from negative infinity to 0 to negative 1, sorry, from 1 to positive infinity, and decreasing from negative 1 to 0, union 0 to 1. Question number 10, f of x equals, sketch the graph of the function f of x equal x power 2 minus 6x plus 12 over x minus 4. For the domain of this function, set the denominator 0, x minus 4 equals 0, then x equals 4. Therefore, the domain of this function is all real number except 4. For x-intercept, we set y equals 0 and find the value of x. Therefore, 0 equals to x power 2 minus 6x plus 12 over x minus 4. Cross multiplication. Then x power 2 minus 6x plus 12 equals 0. Solve this by quadratic formula. A equal 1, B equal negative 6, C equal 12, square root B square minus 4AC equal to B square 36 minus 4 times A times C equal to square root 36 minus 48 equal to square root negative 12, not a real number. Therefore, there is no x-intercept. For y-intercept, we set x equals 0 and find the value of y. Therefore, y will be equal 0 minus 0 plus 12 over 0 minus 4, 12 over negative 4, negative 3. Therefore, negative 0, negative 3 is a point of y. For symmetric, the function is f of x equal to even term minus even times odd, odd plus even over odd minus even. The answer is even minus odd, neither plus even, neither over neither. Therefore, the function is not symmetric with any axis. For vertical asymptote, we set the denominator 0, x minus 4 equals 0. Therefore, x equals 4 is a vertical asymptote for this function. For horizontal asymptote, we find the limit when x approaches to negative or positive infinity for the function x power 2 minus 6x plus 12 over x minus 4 equal to infinity, since the power of the numerator is greater than the power of the denominator. Therefore, there is no horizontal asymptote. For slant asymptote, we find the result of dividing x power 2 minus 6x plus 12 over x minus 4. Since the degree of the numerator is 1 more than the degree of the denominator, and there is no common factor between numerator and denominator. X power 2 divide x times x power 2, x times negative 4x. By subtracting x power 2 minus x power 2, 0, negative 6x plus 4x, negative 2x plus 12. Negative 2x divide x, negative 2, negative 2 times x, negative 2x, negative 2 times negative 4 plus 8. By subtracting negative 2x plus 2x, 0, 12 minus 8, 4. Therefore, y equal x minus 2 is a slant asymptote for this function. To find the interval of increasing and decreasing, find f prime of x equal to the denominator x minus 4 times the derivative of the numerator 2x minus 6 minus the numerator x power 2 minus 6x plus 12 times the derivative of the denominator 1 over denominator square. Simplify this function x times 2x power 2, x times negative 6, negative 6x, negative 4 times 2x, negative 8x, negative 4 times negative 6, 24, minus x power 2 plus 6x minus 12 over x minus 4 all power 2 equal to negative 6x plus 6x, 0, 2x power 2 minus x power 2, x power 2 minus 6x, minus 8x, 24 minus 12, 12 over x minus 4 power 2. Set it equals 0. Then x power 2 minus 8x plus 12 equal 0. Analyze by experiment. 2 bracket equals 0, x, x, negative, positive, negative, negative, 12, 6. Either x equal 2 or x equals 6. We have two critical points. Also, the first derivative is undefined at x equal 4, but 4 is not within the domain of this function. Therefore, we find the sign of the first derivative before and after this critical value, 2, 4, 6 values. Before 2, take 1, 1 minus 8 plus 12, 1 minus 8 minus 7 plus 12, positive value. Between 2 and 4, take 3, 3 power 2, 9, minus 8 times 3, 24, plus 12, 9 plus 12, 21, 21 minus 24, negative value. Between 4 and 6, take 5, 5 power 2, 25, minus 40 plus 12, 25 plus 12, 37. It is also negative value. When x greater than 6, take 7, 7 power 2, 49, minus 8 times 7, 56, plus 12, it is 61 minus 12 minus 56, it is positive value. Therefore, when x equal to is local maximum value for this function, when x equals 6 is local minimum, and from negative infinity to 2 union 6 to positive infinity, these intervals are intervals of increasing, and from 2 to 4 open interval union 4 to 6, these intervals are intervals of decreasing. And 2, f of 2 is a local maximum value for this function, and 6, f of 6 is local minimum value for this function. To find the inflection point and the intervals of concavity, we find the second derivative. If w prime of x equal to derive this function, the denominator x minus 4 power 2 times the derivative of the numerator 2x minus 8 minus the numerator x power 2 minus 8x plus 12 times the derivative of the numerator 2x minus 4 power 1 times 1 over denominator square x minus 4 power 4 equal to factorized by x minus 4 for the 2 term in the numerator, From the first term, we have x minus 4 times 2x minus 8. From the second term, we have 2 times x power 2 minus 8x plus 12 over x minus 4 power 4. Reduce x minus 4 with x minus 4 power 4 and open this brackets. In the denominator, we have x minus 4 power 3, x times 2x, 2x power 2, x times negative 8, negative 8x, negative 4 times 2x, negative 8x, and negative 8 times negative 4, 32. Negative 2 times x power 2 minus 2x power 2, negative 2 times negative 8x, positive 16x, and negative 2 times 12, negative 24. Negative 8x minus 8x, negative 16x plus 16x, 0. Therefore, the second derivative will be 2x power 2 minus 2x power 2, also 0. 32 minus 24 is 8 over x minus 4 power 3. Set it equals 0. Cross multiplication, 8 equals 0. Contradiction, there is no critical point. And the second derivative is undefined at x equals 4, but x equals 4 is not within the domain of this function. We find the sign of the second derivative before and after 4. Before 4, take 3 minus 4, negative 1, negative 1 power 3, negative 1, 8 over negative 1, negative value. When x is greater than 4, 5 minus 4, 1, 8 over 1, 1. Therefore, the function is convex from negative infinity to negative infinity to 4. The function is convex, and from 4 to positive infinity, the function is concave and there is no inflection point. The graph of this function will be, this is the axis. We have a vertical asymptote at x equal 4 and slant asymptote y equal x minus 2. This is 2, negative 2. We have a slant asymptote and we have y-intercept at 0, negative 3. This is the graph of this function. The function is convex from negative infinity to 4 and concave from 4 to positive infinity, is increasing from negative infinity to 2, decreasing from 2 to 4, and decreasing from 4 to 6, increasing from 6 to positive infinity. Question number 11. Sketch the graph of the function f of x equal x square root 4 minus x. For the domain of this function, we set 4 minus x greater than or equal 0. Therefore, 4 greater than x or x less than or equal 4. The domain is from negative infinity to 4 with 4, or real number from negative infinity to 4. For x-intercept, we set y equals 0. for x-intercept, set y0, 0 equal to x times square root 4 minus x. Quadratic both sides, then x power 2 times 4 minus x equals 0. Either x power 2 equals 0, then x equals 0 is a x-intercept for this function, and 4 minus x equals 0, then x equal 4 is also x-intercept for this function. Therefore, 0, 0 and 4, 0 are the two x-intercept points. For y-intercept, set x equals 0 and find the value 0 times square root 4 minus 0 equals 0. Therefore, 0, 0 is only y-intercept for this function. For symmetric, the function is odd function times square root even minus odd, even minus odd, neither square root, neither times odd, neither. Therefore, the function is not symmetric with any axis or origin. For the vertical asymptote, there is no vertical asymptote since the function is not a fraction. For horizontal asymptote, the function has no horizontal asymptote since the limit when x approaches to positive or negative infinity is infinity, and the function has no slant asymptote because the function is not rational function. We find the first derivative for the increasing and decreasing interval. The first function times the derivative of the second, negative 1 over 2 square root 4 minus x, plus the second function times the derivative of the first function 1. Simplify this. Negative 1 times x, negative x over 2 square root 4 minus x plus square root 4 minus x. Common denominator, 2 square root 4 minus x, negative x plus 2 times square root 4 minus x times square root 4 minus x, 4 minus x equal to negative x plus 8 minus 2x over 2 square root 4 minus x equal to negative x, 2x minus 3x plus 8 over 2 times 4 square root 4 minus x. Set it equals 0. Then negative 3x plus 8 equals 0. Then negative, 3x equal 8. Then x equal to 8 over 3 is critical value for this function. Also, x equal 4 make the first derivative undefined, and 4 is within the domain of this function. Therefore, x equal 4 is also critical value for this function. We find the sign of the first derivative before and after this value, 8 over 3 and 4. When x less than 8 over 3, take 0 for example, negative 3 times 0, 0 plus 8, 8 over 4, it is positive value. When x is between 8 over 3 and 4, 8 over 3 is 2.6. Take 3, negative 3 times 3, negative 9, plus 8, negative 1 over positive value, negative value. when x greater than 4 is not within the domain of the function. Therefore, it is out of the domain. Therefore, the function has a local maximum value at x equal 8 over 3, and the interval of increasing is from negative infinity to 8 over 3, open interval. It is the interval of increasing, and the interval of decreasing is from 8 over 3 to 4. And 8 over 3, f of 8 over 3 is local maximum value for this function. For the inflection point and the concavity intervals, we find f double prime of x equal to, this is the first derivative, the denominator 2 times square root 4 minus x times the derivative of the numerator, negative 3, minus the numerator, negative 3x plus 8, times the derivative of the denominator, 2 times negative 1 over 2 square root 4 minus x, over denominator square, 2 square 4 times 4 minus x. Simplify this. Negative 3 times 2, negative 6 square root 4 minus x. Negative times negative, positive. Reduce 2 with 2, square root 4 minus x, and in the numerator we have 3, negative 3x plus 8 over 4 times 4 minus x equal to, common denominator for two terms in the numerator, square root 4 minus x times negative 6 square root 4 minus x, negative 6 4 minus x, minus 3x plus 8 over 4 times 4 minus x equal to, negative 6 times 4, negative 24, negative 6 times negative x plus 6x, minus 3x plus 8 over square root 4 minus x times 4 minus x, 4 minus x to the power 3 over 2 equal to negative 6x minus 3x, 3x, negative 24 plus 8, negative 16 over 4 times 4 minus x, all to the power 3 over 2. Cross multiplication, then 3x minus 16 equals 0, 3x equals 16, x equals 16 over 3 is greater than 4, not in the domain of the function. Therefore, there is no critical point, but the second derivative is undefined at x equal 4, and 4 is within the domain. Therefore, x equal 4 is a critical point for this function. This is 4. When x greater than 4, it is out of the domain. When x is less than 4, the function is negative always. Therefore, the function is concave, because if we take 3, 4 minus 3, 1, 1 to the any power is 1, the denominator is 4, 3 times 1, 3 minus 16 is negative value. The graph of this function will be the domain is from negative infinity to 4, and we have a local maximum value at x equal 8 over 3, this is 8 over 3, it is 2 point something, 8 over 3, and 0, 0 is x and y intercepts. This is the graph of this function. The function is increasing from negative infinity to 8 over 3 and decreasing from 8 over 3 to 4 everywhere. See you next lesson.